To create the Lambda function on the Java, I would use the IntelliJ IDEA, and we create the new project. And this is project. Can use the command line up for this example, and afterwards we can add some unit tests instead to the logic, and then we can put the some name in this, and it would be some demo one, for example. It will be some namespace. This namespace is actually from the existing shopping bot, which you can find on the GitHub. Link will be provided in the description. So the project name is like this, and we hit the finish button. We have the project, basic project on prepare it on Java. Just wait while it is built. So the main function we can use just for testing, for example, but we would need to create the jar file with our component. So for this we would need to create class new shopping bot lambda, and this class would have some method in it. And let's just generate the class itself. And then in this class we would create the method which would implement the particular interface, and this interface is the interface from AWS SDK. To be able to do this, we go for the project structure, and we go for libraries, hit the plus, and load the libraries from Maven repository. And within this repository we would search for this library and select the latest version of this, and we can download it here, and if we need we can use sources and javadoc. For some extra function of Lambda we need also to add this SDKs, and we select the latest one. Just wait a little bit when it populates this all, and then we download it and hit OK button. So now we would have to be able to use the classes from those SDKs. Right, and also we, as a bonus, we got Jackson framework to work with JSON if we want to work with the JSON in a more efficient way. In our example we would not use it, but we can have it out of the box within this. Then you can check what we have here. We have the dependencies, and those dependencies. Okay, we can export them, and then we also can hit apply button and hit OK, and then we can implement the interface this, and then we would need to import the class and implement the method handle request actually. So this is our context, and this is the input which would be sent by Lex, and this is the output which we would need to request. For Java here it would be actually sent the map with such structure. map with the string object structure. Then we can implement this method with the map, and then we can return some object, and I would call it new lex respond. This object will be automatically translated to JSON, so we don't need to do this. We can use the normal objects, and this is very convenient. So we will create the lex respond class. Lex respond class need to have a particular structure. This structure will be similar to what we have here, and this is dialog action, type, fulfillment state, message, content, etc. Amazon Lex documentation contains development guide available in HTML and PDF, and I would recommend to download it. And this guide has this section to create the custom bot, which contains the structure of those messages which we supposed to send as the response, and Lambda function gets as the request. So bot name, alias, current intent, etc. Optionally, it also can contain session attributes to share data between different intents. So we continue with extending the lex respond with according the structure of this response. So we need to have class dialog action, and then we need to have types, type and fulfillment state within this dialog action class with the type close, and with the fulfillment state fulfill it. And it also would contain the inst of the class message. We would create and then we create the constructor, and then we need to create getters. So all those fields would be used to create the JSON response. And then the message would get the content type as a plain text and some content. Message, right? And we would create the console. And we create fields, and we generate getters for both fields. So this way and then we create the constructor for in the lex respond. With private field and with the getter for this field. So now we get two objects within the lex respond dialog action, this one, and message, this one, and message contains content type and content. Afterwards we can also add session attributes collection. The next step would be to create the new artifact as the jar file. We need this to put this jar file to the function. And to create this artifact, we go to project structure, artifacts plus jar, and from models with dependencies. So we extract this model and we extract to this jar file from libraries. Hit OK, and then we see in the output layout we see all those libraries which we need to be extracted to the jar file, and then this is the path to the folder where jar file would be located. So copy it, and this is how the name of the jar file would be. To be able to rebuild jar file every time we build the project, we can tick this checkbox. So OK, and we build the project. And here we see artifact in out folder, and this artifact contains this jar file. So then we go to the Lambda section with the functions, and we create a new Lambda function from blank template, and we call it shopping bot Lambda, and we use Java 8 as the runtime, and we upload this jar file, and we go to the jar file folder, we remember it, and this is our jar file. Choose, and it is uploaded. We don't need for now any environment variables, but we need handler and roles. For the role we use existing role which created earlier, or with this Lambda basic execution, or we can create a new one if we need. So for the handler we would have to choose class name with the package name, and then specify the method which is used within this Lambda function, and in the hint it is shown how it looks like. In this Lambda function it would be used this method within this component, and then we go to next, create function, then we're ready to go. Here we can update afterwards the function package with this upload button. We can specify in the actions test event which now is automatically created as this, but we would need to have something like this with our intent, slots, bot name, etc. We have similar in the another function, we can borrow it, and this is just for testing, it is not used in real environment. So I can go to this test environment and copy this event, and then we go to our just created environment. So we have the shopping bot, confirmation status, name of the intent, and we are trying to order 2 amount of bread with a unit float. And if we hit save and test, we would get the response to which we specified in the content. To customize this content, we need to get the particular data from this input, and this input would contain the map and this map would have the same structure as we've seen here. So if, for example, we need to get the bot and its name, we need to get it from maps, so we can have this content message. Okay, for example, a request came from the bot, and here it would be bot name get, and the key would be bot, and it would be another map. And this map would contain name, alias, and version, so we need to get the name for the bot name. And this bot name we would put here. And then we would get this content like this. Let's check this out if it works. So we need to rebuild the project. It would rebuild the jar file as well, because we have this checkbox ticket. And then when it is compiled, we navigate to the function, our function, and upload fresh version of this jar file. And then we can hit save and test. And here we have the new content request came from shopping bot. No, this is correct actually, and we got this shopping bot name from this. If we change this bot name and we save and test it, and we can see the content has been changed. So of course we need to take care about the possible not existing keys, and for this reason I would create some factory method which would create some class for us, and this class would be something which we would work, which would be more convenient to work. For example, if we would get the class like let's request, and we would create the request, let's request set bot name, for example, and it would be bot name, and then we would create the property. So we can create the intent name. We need to get the current intent and get its name the same way as we did for the bot name, for example. Then we would use this lex request get bot name, and we can create the method for this. Create lex request, and then we can actually move it to another file. And then we see that we have the factory which hides all this logic inside, and we just get the lex request instance with some properties in it. Then we get information about the current intent. It has the name and has the slot. So current intent is also map. Lex request, it would contain the intent name, which would be in our case the department name. We can put it as department name. Alright, so we can save this as the property. And what next? We need to get the slots, and slots would be also map. So it would be the same for slot bakery product and bakery department unit. And we would call it not bakery product as a property, but just a product. Because for other departments we would need to make general properties, but for particular slot names. And name of the slot is unique within scope of your account. So we'll get this department unit, and we would create the unit property and setter for this and getter for this. When we get the another request from the another intent, we would have to use the if else conditions to figure out which particular name of the slot we should use for this intent, and this would be extra logic. Now we populate the this Lex request with the amount, product, and unit, and we have this department name, we have bot name, so we can improve our response content message with all this information. So let's create this syntax. Of course, this is the simple use case how we can use input values and how we can populate the customize our output content, but it can be more complex logic. Of course, we can analyze the units, amount, product, department, whatever, and we can align it with internal state, which can be saved within the some database. For example, we can also utilize session attributes within this conversation, and we can change the type from close to failure. So when we have some issues with our order, so we build the project, it would update this jar file, and we would try to update this jar file, just upload it and save and test. We would get correct message. So we requested from the bot of the department, and we ordered it 2 loaves of bread. If we check out what we actually did, it would be like shopping bot 2, department 2, bread, loaf. So exactly what we need to do, and we can have this 3 bread and a loaf, and then it can be save and test, and let's see. Yeah, so this is shopping bot without 2, 3 and bread. This is how we manage to customize this logic. And what is actually left, we go to this Amazon Lex bot, and we go to bakery department intent, select the last version to be able to edit it, and in fulfillment section we replace AWS Lambda function with our just baked shopping bot Lambda function, and then we save intent and build the bot. And we can start with the whole sentence. I need 1 loaf of bread. And we get this exactly what we expected. So requested from the shopping bot, the name department is our department. We ordered 1 loaf of bread. And the same if we go for these other sentences, as long as the slots are required, actually we see those checkboxes ticked. The chatbot would try to get all information about all required slots. So we start with I need some product, bread. We would try to get, for example, this 1 by 1, how much, 1, and what unit, loaf. And we again get this information from this function because it was sent pre-populated with values for all slots. So it's up and running now. And the next what we would need to do, probably we can extend of course the this with different departments, and we would need to extend our logic so it can support actually meal department, because if we would try to do this request to the meal department, for example, we added the meal department, we change in the fulfillment the return statement to usage of this shopping bot Lambda function, and then we save and we build. Then we try to order the milk. I need 2 bottles of milk. And as we can see, we have the meal department, that's right, and the bot is the same, and we even the same name for the amount, so we get the number. But we have null for the milk product and meal department unit because we don't have these names of those slots for the meal department here. So we would need to customize here. For example, if this intent, this department name would be meal department, it would be milk product, and if it would be bakery, it would be bakery product, and the same for the unit. I have already, and it would be not easy to work with the text literals, so I would recommend to extract it to some constants or final static values and keep it in the structure. So your Lambda function has the same names or keys as the bot used, so it would be easier to maintain, and this is how it can look. Well, the intent section and intent package, and in intent package I keep the information about all those intent lexemes. So department name and how the amount, product, and unit within this department is named, and for the meal department, for the vegetable department, and etc. And when we have this factory, we can use those names here. So for example, when we read the product, we get the current intent and try to get all slots, and this is the slots, and then we check if the actually intent name, or in our case it was department name, if it would be bakery department name intent, so we would, for product, we would use bakery department slot product name, which would be bakery product. The same check for meal department, we get the meal department, etc. So this way we can actually read this in more maintainable way. So now we have the bot operating with two departments. It operates with the Lambda function. It can get within this Lambda function the information from slots using the factory, and then it can operate with these values within this logic of the handler, and it can create the message and put it in the dialog with the clause or fulfill it and send it back. We can also put here different statuses according the logic. The project is on the GitHub, and you can discover it or use in your project as the basis if it is needed. So in this case we can see that we get the lex request the same way we get this from the factory, and then we check on some errors if during this parsing we have any, and we create the failure response in case we have any errors, and the failure response would look like this. So we get the same response but with the type closed, and fulfillment state actually failed, and the message can contain the error, and in the if we don't have the amount or we don't have the product, we would get some response which tell us that something is missing. And if everything is fine, we just create the response with the correct message. So for example, here we build the content. You requested such and such product with such and such unit if we have those units optional. Logic of this function is located on this GitHub repository, and it has some source code inside, and you can explore it and borrow it, fork it. It also have a unit test for this, and we can use those unit tests for easy development. And as an example, I can show that we can create the input as the map, and this input map can be sent to the handler request, right? And then we can see within the unit test for those particular slots or intent name, we can get such and such a result. For example, this is negative intent when failures, and we get this failure because we send unknown intent name, which is not bakery department or meal department. If we run, for instance, those tests, it is all okay now.